Welcome to CVM Stories, the podcast on customer value management. Together, we explore how companies can be more successful and the customers happier through the use of latest customer value management techniques. Learn key commercial and analytical insights from telecoms, retail, finance, and other industries that drive CVM forward.
Welcome to CVM Stories. I'm your host, Egidius. Today joining us is Justas Jankūnas. Justas is here to chat about machine learning, number crunching, data science, and other initiatives related to customer value management. So he will be sharing his insights, learnings, lessons, and more. So let's dive in.
CVM Stories is produced by Exacaster. We help companies take their customer value management to the next level. To stay updated on our latest episodes, subscribe to the podcast or sign up for an email newsletter at exacaster.com/CVM Stories.
So welcome, Justas. It's nice to have you here in the podcast.
Thank you, Gideon, for inviting. That's a pleasure for me to be here.
So I will not lie. I know you for a while. It's already a couple of years, I think. Yeah. So you have a really unique set of skills that combine the data, analytics, machine learning, and business insights and consulting. Could you tell a bit more about yourself for our listeners?
Yeah. So I think it's actually pretty interesting because I believe we are very similar in our background. So actually, as you mentioned, I come from consulting, but before I studied mathematics, when I switched by accident to consulting, and I actually did not do analytical work at consulting. I was IT analyst at first. Then I switched to my next level of career, to retail, where I actually did some analytics, got back to consulting, now in analytics field, and here I am now in Exacaster.
Okay, so what did inspire you to pursue this career, basically, kind of?
Do you want funny answer or the honest?
Obviously, the funny one.
So funny one would be my father. So my father actually did study exactly the same thing, applied mathematics 30 years ago, before me. And he said, study whatever you want, but not applied mathematics because it has no future. For him, it was like, it's not a good choice. Study economics, study banking, study something else real, but not applied mathematics. And I was like, challenge accepted.
So do you have something to tell for your dad now?
No, I mean, I think both his career went okay. My career is also, I think, okay. But the honest answer, I think at school, I just felt I'm good at numbers, at those exact things. I was good with physics. I was good with biology, but I was afraid of blood. So yeah, I would not study medicine when I chose a field which is mathematics. I was actually thinking about IT, about economics. But applied mathematics in Vilnius University had this very nice advertisement. We said, come here, you will get everything. You will get mathematics, you will get physics, you will get IT, and you will get economics. And then you can do whatever you want in your life. So that's what I chose to do.
Wow, this is a very inspiring story. Mine is very similar, but I will not tell it today. So what do you like the most about this analytical part? What drives you there?
I think I was thinking about this before coming here. For me, I kind of like to combine system thinking, understanding how the system works, and then numerical representation of that system so that you can actually explain in hard numbers how things work, whatever that would be. Ice hockey, Formula 1, telcos, retail. So transforming everything to some, for me, more understandable way than just feelings, let's say.
So you're like a super formula guy, describe the world around you in formulas, yeah?
I guess that's how my mind works, or I assume that's how it works, yeah.
So I think this is a very good kind of moment to go further and kind of see how can you transfer your knowledge or your passion from, let's say, what you like about numbers to the telco industry, yeah? So from the analytical perspective and the customer value management area, so how do you transfer this knowledge to this part?
Yeah, so lately, I'm mostly working in CVM area with telcos, as you know, and that's why I'm here in this podcast. I think the idea here is that trying to help the commercial people with this more technical, more numbers know-how, and help them to look into those systems, how CVM works from a numbers perspective. I see this a bit like, I maybe might use sometimes some analogies, and I like cars analogy. So one person is a driver. He maybe don't know how engine works, how brakes works. Another one is mechanic. I see myself as a person who is a bit mechanic, a bit a driver, and he can help those drivers to be better because I know the mechanics. So that would be the idea.
That's a very beautiful analogy, I would say. When we talk about analytical teams, currently there are many roles in analytics. Could you kind of describe at least several different analytical roles that are necessary in the daily life and how they differ?
Yeah. From my point of view, when I started, I actually knew only one role, data analyst, or at least when I was in university. Now we have a lot. If we look at LinkedIn, like each person has different role. When we help CVM team, for example, from that point of perspective and cooperation, I would see main roles, let's say 3 or 4. So one is what I would call business analyst. He usually has to understand a lot of business and have enough technical knowledge to make quick decisions, to be able to crunch the numbers, to find insights, and present those to commercial stakeholders. So he is the closest to commercial team. On the other aspect, we have data scientists. If now we are going to, let's say, deeper mathematics, deeper analytics, we might want to predict some things. So data scientist would be another role who is a lot more into technical details, maybe academia, reading papers, and so on. Of course, both of these people, we cannot live without data. So someone has to prepare the data. It has to be clean, correct, trusted. Usually now these people who do that, they would be called data engineers. So these 3 roles are, I would say, the main roles. Historically, or if the team is small, you might be a generalist. You are a data analyst, you do everything what you need. Today, maybe you do business analysis. Tomorrow, someone will ask you to do a model. So depends on the team size, but the bigger you are, the more roles you can have, and the people would be more focused in that area. Latest role, which currently I think is emerging, is analytics engineer. And here it's, I think people just noticed that if you are business analyst, maybe you don't have enough technical knowledge. If you are very, very like technically capable, then maybe you don't have enough time to dig deeper into the domain understanding. So in my view, a new role was invented exactly in the middle, who has some technical understanding, some business understanding, and then he can both talk with commercial people, but also with technical people, and be the gap, bridge the gap in the middle.
So for me, all those roles are also kind of pretty new. I see how those roles emerge. And what I understand is that even though those roles sound very similar, all are analysts, or maybe data scientists, they are called differently. But if we go to a more detailed level, just for people to understand like the nuances of those different roles. So for example, how would you describe some simple tasks for analytics engineer versus, for example, BI analyst? Yeah. So if somebody is looking to hire a new person in their team, for example, whom should they look for?
So BI analyst maybe is more straightforward, I would say. So when commercial person comes and he has an answer, so usually he would come either to the team lead, or a team lead would just direct him to business analyst. And he would have some question. He would say, we did yesterday, or not yesterday, a month ago, some campaign. We want to see what was the impact, how many people took the offer, how many rejected it, and so on. And this quick ad hoc analysis would be for a BI analyst. So he has to understand what was the request, what is it about. He has to understand how the business works. And usually he would just use already available data, prepared data to just do quick analysis. He would use tools maybe like Tableau, Power BI, Excel for quicker analysis, a lot more interactions with commercial people. He would go to the meeting, present his analysis. He would adjust when the analysis based on feedback. On analytics engineer, I would see him a bit more like technical, less facing the customer. So he would either create processes which are working in production constantly, like daily, or usually monitor those processes and make sure they are like really, really working. And if something is failing, finding the reason why is it failing. Is it some more like, let's say, a reason coming from the data itself? Something is changing in our data sets, some data is missing. Of course, it's a bit technical, but still it's more like from the domain background. Or it's a technical problem. Maybe our server is now updated and some library started crashing and so on. So for me, analytics engineer, he understands this like full end-to-end process. BI analyst would be more like customer facing. By customer, I mean commercial people most.
So if I understand correctly how you would discriminate those roles, so BI analyst would sit next to customer value manager, deliver insights, etc.
Yes.
And analytics engineer would work more like implementing the processes end to end, whether it would be campaigns or I know some kind of recommendation processes or just data transformations that are contributing to analysis, etc.
Yes, yeah? And I would expect analytics engineer to write code. For BI analyst, could be an expectation that he could not know how to write a code. He might not need to use any Python. I think in my career, when I started and I actually joined the retailer, I saw some analysts who are using just Excel and they are perfectly good with that. We don't need to write any single row of code because the data is prepared. We do analysis, we find the insight, we present the insight to senior management. Senior management is happy. So that could be also a distinction.
Okay. So now, as we have some clarity on what are the different roles of analytics, how would you say, what are the key aspects to make sure that these roles are integrated really well into the CVM processes, into the broader team, and how do you see the collaboration? How do you see the successful collaboration between analysts and broader CVM team?
My personal belief that the collaboration has to be very tight. So ideally, actually, and some organizations do that, the analysts, they sit in CVM team. They might do data analysis, but we actually work day to day together with them. So the more interactions are together, the better is the result. It's like this mechanic and driver. And let's say in sports, if you want to win Formula 1, you cannot like go and build a car without talking with driver, and when driver drives it without talking with mechanics, most probably that would fail and you would not win Formula 1. So here I see also the tighter the cooperation is, the better. Of course, some roles, we have to be maybe centralized because if some data scientist would sit together with CVM, maybe he would not have enough tasks. So he might do different tasks or for different CVM sub-teams. So then he might be centralized. But still, a lot of meetings, a lot of discussions together, I think, is the key to success. Because commercial people have to understand what are technical people doing and why. and that has to be exchanged all the time.
And I think it should be the vice versa. Kind of the analysts need to understand the business intention.
Yes, I think that is the most important actually part. That's what I try to achieve in also my team, and I think that's a success. That technical people, we need to speak with business language. We need to understand what is the requirement, and then do their magic, do their work, but also then be able to present it in understandable way. Mechanics and car drivers analogy would be the same. If you are mechanic, you are changing a tire, putting some air, you explain that this will improve your handling, that's why I'm doing that. You explain to the driver, although he doesn't understand other technical details, but you can explain for him why he needs that, why that has to be done.
How this will impact, yeah.
Yes, exactly.
And what challenges do you see in the situations when, let's say, CVM team collaborates with, let's say, analytics team or data science team through, let's say, the tickets only situation, when you know, this is my kind of ticket, deliver me this list of customers, So what are the drawbacks of this type of situation when we have a disconnected teams?
I think a lot of misunderstandings can happen. I would advocate that you need to understand why that person even needs this list, because maybe he is planning to use it for some different purpose, and the translation, because he has some goal in mind, when he translates that into writing, asks to do something, gives a list, I want these customers with those specific features, I know old people who live in that and that area. But when you ask how he's going to use it, if you understand what kind of data you have, you can actually advise him that maybe you actually don't need that, it has to be slightly different. So this might work, the ticket approach, when both teams, we know pretty well each other. It's 1 year we are working together, it's 22nd time we are making the same request, so then most probably it would work. But anything new, anything ad hoc, when we get a ticket, I usually advise, let's have a call, because it's sometimes you maybe don't fully understand the background, why that is raised. It's always better to ask. And if you just communicate in tickets, I think the communication is pretty slow, because you write your question, when you get the answer, maybe 1 hour later, maybe 1 day later sometimes. So, and when you have a final result of the ticket, most probably it might be too late at that moment already.
Yeah. Okay. Let's pivot a bit to, the hottest topic, the machine learning, artificial intelligence, etc. So, obviously, you touched a lot of this area. And what are the key areas in telecom where you see, let's say, machine learning applications?
So I obviously currently work in CVM area, so it's mostly familiar to me. So in CVM, anything predicting about customer behavior, if you can predict how he is going to behave in the future, maybe you can then adjust your actions based on that. So I guess we will dig deeper into that maybe later. But besides that, I think now everything else in telco is emerging. So anything related to networks, for example, predictive maintenance, I think it's a big topic, network optimization, frauds with calls and identifying those. I think also another big area which I don't work, so I'm maybe not an expert in that. And then with now Gen AI on the table, I think there are even more quick entry points, how to use that in other areas. So for example, in customer service, in chatbots, to build a chatbot a couple years ago, it was possible, but if you talk with that chatbot, you could understand it's not a real person. today, I think, especially in those popular languages like English, Spanish, you can make a chatbot and your end customer might not even feel that he is talking with a bot. Of course, when you need to control that chatbot does not promise something too much, so that's another story. But low entry points exist now with GenAI, I think, in other areas.
So if we move to this ML application in customer value management area, could you just give some examples to have a flavor on what are, let's say, common applications that you have touched?
So the most common, I would say, is anything related to churn. So I think most of organizations tried that already, trying to predict if a customer will churn or not, and then reacting based on that. Also, churn can be different type of churn. Customer can decide that he has a better competitor offer, and you might want to stop that customer. Sometimes customer might churn because of different reasons. You don't want him to be a customer anymore because he's not paying you the invoices. That also happens. We call those models either involuntary churn or even credit scoring models, when you proactively try to notice that, oh, this person is maybe risky. So that is one area that's usually quite obvious for telcos. Upsell area would be another. Cross-sell area would be a third one. From cross-sell, I think the one which I saw quite successful in my experience is pre-to-pos. So, for example, we built a model for our client. We already used the model, but the previous model was predicting how likely a customer is to stay with you after he is converted to postpaid for a long time period, let's say 6 months. What we did, we split this into two. So what is the probability first that the customer will convert at all? And then what is the probability that he would stay without looking at the conversion? And we kind of get 2x2 matrix then, and we have those customers who are high likelihood to convert, but they will not stay. They will maybe churn in this involuntary way. Maybe they will stop paying you the invoices because they're just not used to that. Then you have another customer group who is very hard to convert, but we would stay. We are okay. And then you have two more groups. One is like hard to convert, we will not stay, so don't touch this. And the best group is that fourth one. We are high likelihood to convert, we are high likelihood to stay. And I cannot provide the exact numbers, but what we saw, so this conversion model improved the conversions around 3 times versus random guessing. And this TRS model improved staying around 2 times. So
Okay.
I think, I don't remember now exact numbers, but at least twice was the improvement versus random guessing. So it's a big success for a telco. If it's a big telco and we are converting a lot of customers from prepaid to postpaid, to improve your conversions 3 times, when improve staying 2 times, it's like 6 times improvement in total revenue.
Yeah, and this is especially important in the, let's say, regions where income is not maybe very kind of stable for the people, like, I don't know, in some certain South American countries or in Africa or in certain places in Asia, where you can win a lot by just kind of going very precisely and deeply.
And maybe also your offering between prepaid and postpaid is very, very different. Prepaid usually has a lot higher churn. So it's not only winning that you targeted customers who will not churn because of those reasons you mentioned, but also you are increasing your CLV because the customer group who maybe have, 15% monthly churn, you converted them to 2% monthly churn. That's a good achievement also.
Yeah, these are really kind of important and impressive results. But so let's try to connect now kind of the techniques like machine learning with the business objectives. Yeah, because it's like, how do you balance those kind of business goals and what do you need to kind of achieve from, let's say, machine learning perspective when you say, hey, I want to build the most precise machine learning model, use the latest, greatest AI algorithms, etc. And but then there's a business objectives, timelines. Everybody wants to have a result fast, etc. How do you balance those two extremes?
I think one is by talking with this business, but I think entry point in AI in machine learning models is pretty low. So there are tools when you can build those machine learning models in, I don't know, half an hour. Give me data, half an hour later I can give you a model. It will not be a perfect model yet. For perfect model, you need to invest a lot more time. But each organization, we have to decide at which stage we are. Do we want to have a quick and dirty model, which is maybe 80% correct in 20% of time? That could be an option, especially if you start. You don't try to compete in Formula 1 straight away. You first learn how to drive. But if you are pretty good, if you have resources to hire a lot of people, if you have time, then you can aim for this state-of-the-art model, which will take a lot longer. But when it can be achieved, it actually depends on, I think, on your resources.
And probably on your customer base size. If you have 1 million customers, probably it doesn't make sense to improve the model like by 5%.
Yes, and most probably if your customer base is 1 million, those resources which you can spend to manage that customer base is lower. So that's why you would try to find those quick wins. And I would always advise for the quick wins. Just build a model quickly, see if it works, see if you want to continue then. So I would advise always to do iterations. Because I think if your goal is to build, you have nothing, let's say, and when you want to build some state-of-the-art AI neural networks model, and you give yourself 3 months or 6 months of time, then potentially it might fail. Better maybe try to take some sandbox environment, try to take some data which you have today, try to run those simple algorithms which can spit you the answer in let's say, day or a week, and then come back and say, let's invest more time or let's stop here because maybe this model is not feasible. It just doesn't make sense to even do it. And when you stop and you decide to do another model.
But I think this is a super easy sell, for the business person. Like, you come to a CVM and say, yeah, I will deliver you the first results tomorrow. It's an easy sell for them. How do you sell this for the, senior data scientists and data analysts, who always wants, I want to grow, I want to do crazy stuff,
Yeah, that's a tough thing. I think it's one of the hardest things if you work with those, let's say, senior and experienced data scientists. But it's a way to get a buy-in. You show value quick, and then you say, I can invest extra 2 months of time to make it 5% better. And that 5% better, actually, you can even show to commercial people if your base size is not 1 million, but 10 million or even bigger, those 5% better, what does it mean in terms of money? And if amount gained is a lot bigger than amount spent, potentially commercial people will agree on this. Otherwise, as a data scientist, maybe I want to build something new, what I want to learn in those 2 or 3 months, but my ideas will be rejected. I want to show something first so that people would have a buy-in and they would allow me to work those extra 3 months. So I think we always are, or mostly we are, unless it's a huge organization with like really data scientists who really do data scientist work. But if we are in those a bit smaller organizations, we are at the same time delivery people, but we are also selling that idea. It might not be that you create a proposal as a data scientist, but you still have to convince those commercial people. And here this business understanding comes in very handy. Why they would want to even do that.
So basically trying to link back to the impact that you're actually creating, yeah?
Yes, and the more people in the team do that, the more successful you will be.
So, quick and dirty model in a day is a easy thing to do nowadays when we have good tools, etc. But, having a tool to create a machine learning model, it's not everything. Yeah. We have some work to do before. And usually it's related with the data, So what are the most common challenges that you see actually when preparing to build the machine learning models?
The data quality is a challenge because you use data to build those machine learning models. How big or how exactly is the challenge? It might be hard to understand if you're not in this field, and I believe maybe not every listener is, so I will try to give an example. Understanding how machine learning models work on telco data is a bit complex, I would say, but my example would be, imagine you want to train a model which recognizes is it a cat or a dog on the photo. So everyone can understand that. Imagine you have all your photos which you are trying to train on are blurry. Like you don't see the cat clearly, you don't see the dog clearly. So that's a data quality issue. And if you use that data to train the model, you will get a model which is not very accurate. Especially if you trained it on blurry photo, if you give a very nice photo of a cat, most probably it will not recognize a cat because it was trained on blurry photos. So that's what we call problem with features, like we are not exactly correct. Now you might have a problem with target variable. Imagine some cats are marked as dogs and some dogs are marked as cats. That's even bigger nightmare. Why this is easy with photos? Because as a person, you can look at the photo and this is an incorrect photo. You can take it out of the set. But now when you look at CVM, if you see a person, you see, okay, it's Egidius, his usage is like 100 minutes, he spent 20 euros, he spent 0 gigabytes. How would you know if that's correct or not? You are not Egidius. I am not Egidius, I don't know. So this challenge is very big, and especially for analyst team, I think it's also big, especially if analyst team is external, like in this case, let's say we are. Then here, a lot of cooperation has to happen to make sure that this data is correct. And we have techniques for that. So for example, when we do machine learning models, I always advise to start with exploratory data analysis. So first you agree on the target variable, you make sure that all the cats are marked as cats and all the dogs are marked as dogs. And that is actually a complex task because you need to say specifically which features mean that this is a cat or this is a dog. So that takes time. It sounds easy, but usually it's not.
Well, we'll try to mark dog and cat for 10 million people, yeah?
Yeah, but try to mark it based on, I don't know, pixels or something. Because you sometimes, if we, let's say, we did a churn prediction, and you say, okay, we have this person who churned. We see that he is inactive next month. Do we consider him churner? And the client says, yes, we consider him churner. But 1 month later, he is back active. Do we consider him churner? Because he is back active after 1 month. A reconnection happened. And there are a lot of these corner cases, which you need to define correctly. What do you mean by churn? Because otherwise, your prediction will not be churn. If you define target variable slightly different, your prediction is also slightly different. And when we do the EDA, to understand the features. So for us as a data scientist, it gives early sneak peek which features might be more important for this particular target variable. For example, if it's a post-pitch churn model, usually what we could expect that someone who has Apple device is less likely to churn than someone who has some other device, at least in the countries I work with. Maybe in Western Europe is different. But that's one thing for us to understand. But another thing is showing that to client, and they see trends. They see, okay, maybe more than half of our base have Apple devices. Is that really true? We just start to think because we know their base, and we can spot those incorrect things in data. So we use that twofold. for us to better understand the data, but also as a way to confirm with commercial people that this data, which we get from data sources, actually makes sense. There are no huge problems. So it's like kind of showing those photos back to a customer, but on an aggregated way, because one by one you cannot review the photos.
Yeah, I think when we talk about data quality, the really not obvious part is that the data quality starts somewhere far, far away in the systems, and the data quality issues are not spotted until the very end, until the offers are delivered to the customers, etc. And sometimes even never, if you don't do this type of deep analysis.
And one important thing is that AI is not yet smart to notice those things. For AI, it's just a set of numbers, and it works with those numbers. It's only people can notice those problems. Of course, you can detect outliers and all this thing. This is traditional, but usually the problems which we see, they are not outliers, they're just incorrect data. And that incorrectness itself, it can be noticed only by people who are the closest to the commercial area.
So we are kind of moving, we moved a bit step back to talk about the data, and we see that kind of the really good machine learning models start there. What is your kind of checklist when you are actually designing the full model to kind of to make sure that, okay, I will do the right thing? So number one, you said it's defining the target variable.
I always advise to start, even if it's one day type of project, but when you have to spend first hour to define the target variable. Then the next thing, I always suggest to do EDA. Of course, if you want to build the model in one day.
What is EDA?
Exploratory Data Analysis.
Okay.
So you take more or less all the categorical variables, or you take continuous variables and convert them to categorical. Let's say age, you say, okay, these are young people, these are middle, some older folks, and so on. And then you split, so how each group is likely to churn. And maybe you will see that young people are more likely to churn in, let's say, in voluntary way. We are students, we are because of those reasons, when usually the older people, they are less likely to churn in voluntary way, but maybe voluntary because we are more price sensitive, and if competitor has better prices, we can switch. So looking at that type of view, one-dimensional view into how your features predict the target variable. So I always advise to do that. Of course, if you have a very, very short time period to build your model, then you might skip this, because you will see similar things from feature importance calculations from a model. But for bigger projects, that is a way to spot issues with data.
But is it also the way how you build some intuition about why do these machine learning models work? And
Yes, it actually helps to convince commercial people how that black box works. Because especially with neural network type of models, it's really black box. Even data scientists cannot explain why exactly this person got the score, because there is no real formulas behind that. But you get intuition. He used Apple device, he is young, he lives in capital city, he uses 20 gigabytes of data. My intuition is that it will be less likely person to churn. When versus someone who is maybe a lot younger, who doesn't have stable income yet, based on our understanding of average person that age, maybe he had some complaints to customer service. Maybe he's not using a lot of resources, but paying a big amount of money for his current plan. So then my intuition is that this is a high churn case. So looking at this one-dimensional way allows you to build that intuition, especially for commercial people, allows them to trust in the model, and very important, allows them to make sure that the data is correct. Because if it's against their intuition, there are two possibilities. Their intuition was incorrect, which happens sometimes, or the data is incorrect. And you need to fix the data, which then would meet their intuition, that it would work as expected.
So I draw kind of three very important aspects. So number one is basically alignment between the data analysts and the kind of commercial part. What is the exact thing that we are trying to predict? This is the
Exactly.
prediction variable, and doing some sanity checks that it's really
What kind of data we are going to use for predictions. When we go to actually building a model, this stage could be a bit data scientists can go to their garage and do their magic. But then the important part is how can we prove that the model is actually correct, that it does what it is supposed to do. So that stage, when data scientist brings the working model back, we usually present for a commercial stakeholders some presentation which tries to showcase that this model is actually better than random guessing, and that this model is actually better than previous model if such model existed. And the more better it is, the better will be the commercial results. So this stage to converse commercial people is, I think, very important, but very hard. Because what you are trying to explain is the technical part to a person who we would not expect is technical. So mechanic tries to explain why it is important to change some part in your car, but you as a driver, you don't know and you can only trust him. So he needs to bring a lot of evidence why that part needs to be changed. So here it's also like we have a model working, trying to convince that actually it's best we can achieve.
Here I have a very tough question for you. So I remember from my early days when I was trying to present my, I think, churn prediction models, but business people sit in front of you and you are trying to explain what does the area under the curve means, what does the rock means, what does the confusion matrix mean. And it's, the things that I remember is like that people would not get what I am saying at all. How do you cope with that?
I tried to find some similar explanation. I think Albert Einstein once said that if you cannot explain any concept to a 6-year-old, it means you don't understand it yourself. I'm not saying that I can explain machine learning model to a 60-year-old, but at least trying to say in a simple way. So for example, like our rock, it's some nice curve. You can try to explain that the more it's like has this shape, the better it is. I don't know if people will be convinced, but what actually is behind the scene of that? So you order all of your people from the very best to the very worst, and the more best people are actually correctly identified, the better is our rock. So it means that it's not a random order, but really those people who have higher churn, they are at the top of the list, and those people who have lower churn at the bottom of the list. So I try to explain in these ways. I don't know if that explanation was good enough, but then actually I like to draw a lot, try to show those concepts in a visual way, and maybe that helps, because listening to a concept is one thing, seeing it on the paper is additional piece of information. So you have visual information, then audio information, and that hopefully helps. But it's like people study for bachelor's degree, then master, then PhD. Maybe we study for 10 years. So it's not, you should not expect that this can be explained in 5 minutes, but at least how the system works. Don't try to explain the black box inside, but how inputs are in and how do you get outputs. I think that can be tried to explain. And if at least some people understand and get a buy-in in commercial team, then we can share that with their colleagues, and slowly this buy-in can happen. But this is a tough thing.
And now imagine, we did this 2 days project. We have a really great model that predicts which customers are most likely to convert from prepaid to postpaid and stay. Everybody are happy. Like the commercial team says, yes, let's do this. Let's run the campaigns. Let's go into production. Yes. And I think this part was not obvious for me, I don't know, 10 years ago, etc. But now we have this concept, which is kind of machine learning operations. So could we now move to the part when, we are designing the models, having fun, etc., and to applying those models in the production on a daily basis? How would you kind of describe this part? Because this is a totally new beast for most of us.
So I think models running in production, they existed even 10 years ago. If you create a model, you can find a way to launch it in production. But what kind of problem you would have, it would be stability. Sometimes maybe for some reason, it would stop working. So that can happen. Now, MLOps try to avoid of these situations, how to make everything more robust, especially in production. Because sometimes you cannot have no prediction. So in simple terms, you want to have several environments. One is for your sandbox. Usually we call that sandbox, or sometimes people call it development environment, for this playing. And you can do anything you want in that environment without impact to your production, because it's a completely different, isolated environment. And whatever you do, it's impossible to break that production environment. They have to be separated in some way. And then once you build your toy and you're happy with it, it has to get through some testing stages before getting into that production environment and exchanging the currently existing model. Because what usually used to happen before MLOps, you would create a model, you would launch it, it works fine, but sometimes something then would change. Either you retrained the model, you maybe added new features, then deployed it to this production, fake production, and then maybe those features don't exist in that production environment and it would fail. So here you are trying to ensure that this does not happen. And how do you ensure that? So you have this sandbox environment, then you train the model and you move it to staging environment, which is exact replica of production. So in staging, you can do the testing. If in staging environment, the model runs and it runs fine as you expect, it means it will also run in production. And only at that stage, you then move a model into production. Of course, all of this is rather technical thing to do.
I think kind of MLOps emerged because there were really kind of bad examples or issues in the production. Yeah. So, for example, if we would go back to the cars example, yeah. So we have a self-driving cars, and let's say if you deploy a new model in a self-driving car and there's a bug, you instantly get a feedback by crashing the car. You know, it's like when the model does not work, you have a really tough consequences. But for example, when you run models in telco, usually, it's in the form of some personalized campaigns. And when the model fails, you see the failure, for example, with when you send empty emails to your customers or you send some random offers, etc. You get the feedback really, really late in the process. Yes. So I think this is kind of starting to use MLOps actually helps to avoid this very long feedback loop, yeah?
Yeah, that's correct. And you try to ensure that if you have those problems, you would notice them before, at least not in the production environment. Of course, it depends on the nature of the problem. Sometimes you might think, okay, in UAT, it works fine when you deploy to production. But if it was like actually the concept was incorrect of a model, then yeah, it could technically it works fine, but still the result might be not very good. But these situations when all the predictions are 0, empty emails and so on, you should then catch those in the this staging UAT environment, which is before the production.
So when I was studying statistics, for example, and when I have had my first, let's say, machine learning classes, etc., what they taught me is like opening notebook, writing some code, etc. But nobody taught me about, production environments, UAT environments, staging environments. How do we kind of automate the process there? Am I the only person from the data analytics world that does not have these concepts, or is it like a kind of do people struggle with that?
No, I think it's widely known situation. So usually, if you are in data analytics track, you are mostly working with data and less with those IT technical stuff. And this MLOps concept comes from DevOps. And DevOps originally was more in the IT and programming and the IT engineering area. So these concepts, they are being adopted now in MLOps, but usually current data scientists, they would not have that knowledge. We can only learn it now because it's pretty new concept. So in universities, usually it was not taught. Maybe now some university would start, but I even doubt that, because if you start teaching people about that, so you are making even more generalist person. This is this problem that we discussed at the beginning, that you have maybe a data analyst who does everything, but the bigger the organization is, you cannot have all the people doing everything. So you try to have roles for each one of them. And one additional role would be a MLOps engineer, for example, who specifically understands the platform, how the MLOps work, how this sandbox, dev, staging, prod, these environments interact, what needs to be specifically done for the model so that actually this can be deployed. It's a lot more technical work than just training a model. So usually we just have new roles, and these roles are either filled by data people who want to get upskilled in this area, because world is changing quickly. You cannot expect that if you attended the university 10 years ago, you will work for 40 years in the same field. So either you decide to upskill yourself in this area, or actually sometimes people from IT area, they would say, okay, I'm interested in this new ML area, and I switch to that. So then that person would understand how continuous integration, continuous deployment works, and he can bring those practices. He might know a bit less about how machine learning works. He needs to learn that, but someone needs to learn something. So I think now that's where we are. That's the situation. And these people are really needed. But to reach that, you need to learn a little extra.
So do I understand correctly that, let's say, in the beginning of the conversation, we said, let's try to run quick and dirty models and get result in a single day, etc. When we deploy, let's say, the MLOps environment, does this mean that now it's not a half-a-day project? Now it's like 3 months project to go to production?
It's yes and no. So to go to production usually is yes, because you need to do a lot more robust testing, a lot more stages have to go, a lot more people have to get involved, unless you have one generalist person who knows everything, but that in bigger organizations rarely happen. So it is slower to reach production. However, when you have a MLOps platform which is developed specifically for data science team, usually you have some resources in there which allow you to start quicker. So for example, you have feature store, which you trust. You don't need to find your data somewhere. So the feature store is ready for you. And as a data scientist, you can take your features and you just use them. Maybe you have even target variables between those features. When you have project templates. So you just open a project template, and maybe you don't need to write your code from zero. You just change a couple lines, and then you can start to test first things. So I think with these platforms, initial development is still quicker. But then you have those extra couple steps, staging and production environment, which slow you down. So that exists.
So it means that the value proposition for kind of showing the results fast is still there, but we are way more cautious about going into production, making sure that everything is kind of smooth.
And here important angle is maybe when you first a model, first time it's maybe it will not be too hard to go into production. But the idea is how do you iterate with the model updates? So maybe a couple months later, you found that now this new model works better. Maybe you added new features. Maybe you change the machine learning algorithm itself. And how do you change the old existing model with this new one? So that process also takes a bit more time, but you can be more sure that this change will be successful without downtime, unexpected downtime.
Okay, so you can experiment more and kind of iterate and have and get this progress. Yes. Now imagine, so kind of, I assume that building kind of your initial setup of MLOps infrastructure, it takes time, it costs money. Imagine that you are a data scientist that work inside the customer value management team, and you want to pitch the idea that, hey guys, let's go from kind of really, let's say, not so robust process with many errors in production, etc., to a more complete machine learning operations environment. What would be your pitch for, the CVM team, and say, hey guys, I need to do, 3 or 4 months preparation and give us time and resources for that?
I think it could be a lot of angles. So for each organization, it might different what kind of problems we had. If we had a lot of these situations when the processes would fail, most probably we would build on top of those situations that, if we would have this platform, that could have been avoided, and that's your impact. Another organization might maybe not have those problems, but let's say they develop several models and they take quite long each one of these. It seems like, okay, I did a post-pitch churn model, maybe it took me X amount of months. Now, let's say I'm doing pre-pitch churn model, and again, it will take me X amount of months. And when I do pre-to-post, and again, it will take the same amount of months. If you have a MLOps platform, that would be saved. So the initial start would be a lot quicker because the features exist, everything is ready. You have more or less the same infra where you just iterate and build models. So even from our clients, because we deployed this MLOps environment, we see that initially the first model build was pretty short. It took a lot of time to build the first model, but now iterations are a lot quicker because you have those templates, you have the data, you just put everything quickly. Maybe you just add some additional data. So the sandbox environment, playing in that sandbox environment gets a lot quicker with the platform. And so I would need to understand more background about organization, where to actually make the stress, but there are several areas which could be improved.
Okay. And now, let's say the organization starts with machine learning models and they are kicking off their, let's say, initial projects. How would you make sure that these type of, data-driven decision-making projects that involve machine learning and artificial intelligence usage, how to make sure that the projects are successful and the collaboration between many stakeholders are actually kind of working as you would expect?
I think during the project, it has to be a buy-in from someone pretty senior. Because as you mentioned, both sides have to be really involved. Commercial people, data science, actually even IT maybe, because some new data might be needed. So 3 sides when all of them have to be involved to have a successful development during the project. If at least one side is not so involved, then the results will not be that good, because it's a collaboration. After the project, that's I think the hardest part is now to keep using and keep running it. So especially when the teams, they come for a project. So data science team, for example, we come for the project. Usually expectation is that they will leave and they will do another project. So some proper handover has to happen. Maybe for analytics engineer or maybe for MLOps engineer, how to maintain the models after, but also for commercial people, how to use those models now in production. So I think that handover stage is very important, and then the adoption stage. So the model is not forgotten, because sometimes what also happens, you deploy the model, everyone is happy. We did a great work. It took maybe 3 months. Everyone is like very tired, but now somehow it will magically run. That's the expectation, but it's never happened, because you need to maintain. Like you buy a car, even if it's brand new, you need to bring it to a service every maybe year to change oil and so on. So the same is here. You might have various drifts, concept drift, model drift. Something is changing in your market. Your competitors are doing something else. You might need to retrain the model to make it as accurate again. Some even technical things. Some new libraries are launched. The old ones doesn't work anymore. At some random point, the models start behaving bad or even failing. So MLOps engineer, for example, could be responsible to ensure that. However, in MLOps platform, that's why you use the platform, so such situations would not happen.
Okay, so it seems like if you decide to run a machine learning model in production, it's like a proper IT project. It's like it's a small IT system which needs to be supported and maintained.
Yeah,
it
maybe
has
just
to have SLA, basically.
Yes, that's correct. And maybe just the maintenance is not by IT team but by analyst team. But yes, it will need attention.
Okay, so looking ahead, yes. What do you see upcoming in the nearest future? How do you think it will change the same kind of customer value management initiatives with the kind of what will be the role of machine learning, artificial intelligence in this sphere?
I think machine learning importance will grow more and more. We see with this new GPT development, like if you would ask this question a year ago or 2 years ago to me, I would never predicted that so quick we will have such a general intelligence. I mean, it's not intelligence yet, but the answers are pretty convincing. The amount of knowledge is also like, wow. Because I've been testing those chatbots, playing with them 5 years ago, 2 years ago. We were learning from you, but we were never that clever, you would say. So I think this is a huge improvement, and it's very hard to say what we are going to see a year from now. It might be very, very, very different to how we imagine now. But I think AI and ML will be more and more important in all of the areas, CVM including, because the more brain power you have, or computation power in your machines, the better you can target your customers. And in our daily life as professionals, I would see that AI and ML will make bigger and bigger influence. I don't think that it will exchange us, but it will be a good assistant for us to work quicker, better, in better quality, more efficient, and all that.
Okay. Let's see. I am also very curious of what will happen in the upcoming year, because the pace of change is actually growing. So it will be very interesting. So let's go into the wrap up part of our conversation. And let's go to our kind of standard questions, yes? So could you share your proudest career moments with us,
Yeah, that's a tough question. I saw previous podcast episodes and I saw that these questions are constantly asked. I was thinking about that. As I'm not really myself launching any campaigns or doing that, I don't have those success stories that, I made $1 million for the company. But actually for me, because for last maybe around 5 years, I always been leading as a senior analyst or as a team lead some other people. So for me, I actually feel very good when I see that this person now is actually, I am not needed anymore. He can just deliver in same capacity. He can do my work. So when I see those people who learn from me grow to my level, I think that makes me very, very proud. Of course, I understand it's their own work. Maybe I just added 10 extra %, but still these 10 extra %, I hope matters. So this is what really makes me feel good about this work.
Okay. So, and if we would move to the other side, it's like, could you share some failure stories,
That was a lot more complex. I was actually thinking about any good example. So I managed to find one. I kind of named it too big a bite for you to chew. We had a situation in my previous careers when we would not work with big clusters. We would do all the analysis with our own machines, like more or less like single server machine. And we had a client with a pretty big data set, but nothing huge. And we promised to deliver it in some timeline. And we started working, and apparently everything started to add up. And then our machines, like laptops or desktops, we could handle the data, but that would take just too long. You launch a process in the evening, in the morning you find it successfully finished or not for some reason, and then you need to spend another half a day to even write it. So now we don't have that problem as often. You have cloud services, you have maybe on-prem, but like clusters where the resources are shared and the machines are pretty big. But at that situation, it was pretty tough. We even had to rent big gaming desktop computers to run those loads and do some smart load management between the computers of ourselves. This laptop calculates this specific subset, another subset, the third one does all the joins. So yeah, that was a long time ago, but after that I am a lot more careful. What can I promise to calculate in those single machine environments rather than clusters?
But it is cool that you figured out a way how to do a parallel computing in real life.
Yeah, because you can segment the data. You can partition the data.
Yeah.
Like one country is in one machine, another country is in another machine. So yeah, the same concept works as in cloud, as in cluster computing.
And the last question is, what resource would you recommend for our listeners, to that inspire you, grow you as a professional and as a person?
So lately, I am interested a bit more in dopamine research personally. So there is a book called Molecule of More.
Okay.
So currently I'm still reading it, but it actually explains a lot how people, but also other organisms, they live, how dopamine works, when it shoots, when it's not. So all of this mechanics is pretty interesting, and I think it's would be pretty interesting for everyone also to read and to understand, especially when we are now in this, you could say, maybe pandemic with like social networks, and each social network is more and more dopaminergic. So like previously TV, you would watch TV, news, because you don't know what will happen. And actually that would give you some dopamine because each news would be new. You did not expect it. And when you go to social networks where you get the same amount, but in a lot shorter time. And then maybe TikTok, who you like, 10 seconds each, and it's a boost. So understanding how that works in your brain is pretty interesting. So that would be from my personal development. For my colleagues in the analytics field, I would recommend the book Staff Engineer. You can find it in Amazon. Maybe it's not very widely known, especially at least here in Lithuania. And the book is about how can you grow as a specialist beyond management track. Because I think a lot of companies have is, especially in analytics, you become a senior analyst, and the only option you have, or you think you have, is to become a manager or team lead. But that gives you, you just have to do a people management. And what this book talks about, and this is actually a widely studied concept, apparently outside Lithuania at least, and now even companies do in Lithuania, and we at Exacaster actually follow that concept. We maybe don't name it this way. So the role, we call it staff plus role. So anything above senior analyst, what you have to impact, what you have to think about, and what is not your area of responsibility. So anyone who are interested in this, staff engineering could be interesting book.
So thank you, Justas. It was a pleasure to have you here. Lots of great insights.
Thank you, Gideon.
Thank you for listening to CVM Stories. If you enjoyed the show, please leave us a review. You can also ask us a question about a particular customer value management challenge you have at work. We will happily ask our experts to tackle your challenge in a future episode.